Hello, welcome again to Bergson and the Holographic Theory of Mind ongoing series. This is part 25 on Karl Pribram with a short revisit back to Bohm, who we discussed in number 17. So we'll be looking at Pribram's use of holography and his vision of the holographic brain, and one of the fundamental difficulties involved with his model, namely, again, the origin of the image of the external world, how there's so, and who sees it. Back to Bohm and the fundamental problem hiding within Bohm. And we're looking at some holographic extension, a particular extension, shall we say, of the holographic model, where we end up with some of the most, I think, egregious difficulties, namely no objective reality and worse. Some of this relies on interpretations of the double slit in quantum mechanics, and in that we'll be going back to the beginning to deBroglie and his waves, his original model, which began quantum mechanics and the double slit. Special relativity's misdirect in this whole subject, and of course the fact that electromagnetism has been lost in this whole subject, as we discussed in number 22. So a bit of tying things together. So Karl Pribram's framework on holography in the brain has been massively influential, and David Bohm is closely associated and related. We reviewed Bohm in comparison to Bergson in number 17, as I noted. With Bohm, Pribram underlies the holonomic brain framework that is very popular. As I noted in number 17, Google searches bring up enormous numbers of results in this framework on holography in the brain, Bergson missing completely. A couple comments with respect to the Bohm piece indicate to me that there's a need to examine the source here, namely Pribram, the source of this holographic conception of the brain. And this will again get equally to the fundamental problem with Bohm as well. The real core that I wish to emphasize, the difficulty that's truly essential. This fundamental problem, unfortunately, leads inevitably to very stretching extensions of both Pribram and Bohm, which feature the denial of the objective world, or all is a vast illusion. Pribram was a student of the great neuroscientist Karl Lashley. Now Lashley, we noted earlier, was a theorist on the syntax of behavior, talking about it in number 9 in Free Will, the implications of which are yet truly to be understood and engaged, particularly as far as sentence comprehension is concerned. Karl Lashley did experiments with rats. For example, he trained them to learn a discrimination task. Mr. Rat there had to learn whether the circle or the triangle led to the hamburger. If he picks the triangle, he gets the hamburger. So he has to discriminate between triangle and circle. Then Lashley cut out parts of the brain to see if he could destroy the memory. No matter how much he sliced, he could not destroy it. He did multiple experiments over and over, slicing and dicing in every way he could conceive of. Could not make that discrimination understanding disappear. This led to his view that memories are distributed over the brain, or at least over a functional area. They were not located in one particular place. Any part of the area seems to hold the memory. Now notice this already seems somewhat holographic. And I'll note there were theorists preceding Pribram like Longuet-Higgins, Van Heerden, Gabor, that in the 1960s are already talking about the brain and memory as being holographic-like. So this notion, how this could be, became Karl Pribram's quest. So Lashley in 1942 visualized the nervous system of the brain as an organized network of loops, the various links in complexity. the network transmits impulses across the cortex and re-excites the initial points of stimulation. So excitation from any point spreads throughout the system. Given the system is uniform, we can visualize a series of radiating waves, waves of excitation, then waves of extinction or inhibition, and in this, interference patterns will appear. So basically the interference pattern of waves, this time taken across the brain. Lashley noted the possibility of viewing this as a wave pattern on a liquid medium. The crest and troughs reflect the spatial distribution of the wave sources. So fundamentally, you'd have a pattern of standing waves reduplicated throughout a given functional area of the brain. Pribram contended that the mechanism for the transmission of these waves, which Lashley could not find, is synaptic and dendritic potentials, in other words, chemical potentials. He noted the similarity of the behavior of the visual receptive fields with their neighborhood interactions to convolutional integrals, which are used to describe the interaction of waves in the holographic process. Somewhat similarly, we ran across convolutional neural nets in our deep learning discussion, where again in a convolutional neural net, we were multiplying each element in an array over and over again iteratively. So you're multiplying every element by every other element iteratively. And one can get that idea when looking somewhat at an interference pattern over there on the right, how a convolutional integral would be involved in that. So he visualized, quote, the construction of more or less temporary organizations of cortical columns by the arrival of impulses at neuronal junctions which activate horizontal cell inhibitory reactions. When such patterns converge from at least two sources, the design would produce interference patterns. So he was visualizing with at least two sources, waves of inhibition or excitation crossing each other, shall we say, in the cortex and creating interference patterns. This came from his book, 1971, Languages of the Brain. Now, most of Pribram's discussion was devoted to memory and holographic-like aspects of human memory. For example, content addressing. In my discussion of reintegration, the natural memory operation we experience, an event, for example, coffee stirring, drives the memory of the other experiences of coffee stirring that we've had. So in this case, the content drives the recall. And I related this to the structure of the event, the invariance laws describing the event that naturally retrieve all other events with the same structure, as though we're driving a reconstructive wave through memory. The point being, this form of memory is not searching for a numerical address, as in a computer, where a computer word has a numerical memory location or address. And therefore, we're searching through computer memory address by address, looking for a piece of content. Rather, the content itself is driving the memory, driving the process. So Pribram considered the human ability to recognize persons, or as we'll see penguins again, at any distance or angle. He denied this ability to fix holograms, but thought it might be possible for a neural network to have the flexibility of a zoom lens to adjust for size. Perhaps, as he noted, quote, through variable fields analogous to those in electron optics, to produce different gradients in speed and propagation of the network. So we saw the same problem that he's referring to still lingering, still actually remaining strong in our discussion of deep learning nets. For example, Mr. Penguin here can be recognized from different perspectives and different points in perspective as far as his rotations there, yet as the same penguin, or scaled up as a yet larger size version of himself. This was a difficulty yet in deep learning nets. So throughout, however, Karl assumed the storage of experience in the brain, and actually rather very statically so, as we'll see as we move along. But he also turned to the subject of perception, that is, to the very origin of this experience that he's considering the storage thereof. He noted that images can be produced through the stimulation of the so-called association areas of the brain. Normally, he stated, images so produced can be distinguished from those produced by the stimulation of the receptors. But under certain conditions, such as sensory deprivation, or in a sensory deprivation tank, this differentiation between internal and external images breaks down, resulting in hallucinations. You're not sure, you're not seeing something that's actually external to you. The very fact that imaging of this sort occurs, however, and that it displays similarities to the perceptual process, suggests that perception itself is to a large extent reconstructive. Then he asked, what mechanism other than the process of image reconstruction by holography can be thought to perform this function? So this is where he first begins to go to perception as itself a process of image reconstruction, but reconstruction is the word via holography. And so he asserted, from energy configurations that excite some of our receptors, we are able to reconstruct a world out there. In other words, the cup in space on the table in front of us. So in 1971, this is all Pribram had to offer for the image of the external world. His notion of reconstruction is a bit vague. You could ask, is it some other piecing together of elements of the external scene, the cup, for example, which are being registered in the neural processes in various points in the brain, various storage areas in the brain, such that they gain coherence in the brain as a scene, the whole cup perceived globally as a cup? But Karl is arguing that all the neural waves ultimately form a hologram within the brain, the waves of inhibition and excitation from a hologram within the brain. So we'll put a little hologram in the brain, obviously not quite how he visualized it. And then the only way to reconstruct an image from a hologram is via a reconstructive wave. There would have to be a reconstructive wave coursing to the brain and then reconstructing the image. Just like the reconstructing wave set in the picture above there passes through the hologram. And then, of course, we have the problem that the object wave coming up to the eye of the viewer is now specified as the cup, the original source of the object wave, but we have that viewer, and that's going to be the problem. So what is the reconstructive wave passing through the brain? Is it a wave of light passing through the brain? Because somehow you have an optical phenomenon. Ultimately, you have the optical vision of the world out there. So where does this reconstructive wave come from? How does it exist in the brain? How does it exist? What is it? Pribram had no answer, nor has there ever been one. So problem number 2. Assume there is a reconstructive wave for the sake of argument. So it has to pass through the hologram of the scene in the brain. Again, this very static notion of there's a static hologram of a static scene in the brain. And then, in theory, it projects an image externally. But who now looks at the image? The viewer, as the holographic picture always implies there's a viewer looking at the rising waves, specifying the original object wave, the source of the original object wave. So do we have that? A little man inside the brain, an image processor? Problem 3. Supposing we have the image projected out there, how does the image processor now process the image? Again, do we have someone, an image processor, our Homer there, now processing that external image? Well, now you have to explain how he processes the image. Have another man behind him, and then another processor behind him. In other words, ultimately you end up with an infinite regress. So you now need a theory of processing the external image, or a theory of perception of the image, and you're right back where you started. This is why Bergson's resolution of the subject and object problem in terms of time is so important. And we'll go to that shortly. In fact, now. In Bergson's model, the brain itself, in its totality, to include all of its processing, all that we today call computations, forms the reconstructive wave globally. And it's passing through the holographic field, the holographic universal field. That is to say, there is no reconstructive wave inside the brain passing through a hologram that's also inside the brain. So in this concept, the brain, the wave that the brain supports, is specific to a source within the holographic field, i.e. the coffee cup. And as far as subject and object relation and the removing of the viewer, the time transformation of this field, the holographic field, is indivisible, non-differentiable. There are no instants, discrete instants, falling into the past, into non-existence. So there's an elementary awareness and memory defined over the field due to this indivisible transformation and the field's holographic properties, where the state of each point in the field reflects that of all other points. In other words, an elementary awareness defined throughout at the null scale, the most minute possible scale of time. And so the brain, as a reconstructive wave, is specific to a subset of this awareness, then, be it a coffee cup, be it a fly, a butterfly, at a specific scale of time. In this, then, there is no viewer looking at an external image projected. Now, the history of Karl Pribram at this point is, to me, a tiny bit wavy. Per Michael Talbot's narrative in his famous book, The Holographic Universe, it wasn't until Pribram discovered Bohm that Pribram had his holographic insight. Yet, I'm aware that Pribram's physicist son told his dad about Bohm in 1975. That is after 1971 and the book Languages of the Brain, which we've been quoting from. So I don't know how he could have not known about holography when he was writing about holography already, before meeting Bohm. In any case, he began working with Bohm, and he began talking about the external world as being a vast set of waves of various frequencies, a sea of frequencies. And he began talking about Fourier transforms, which are mathematical transformations of waveforms, as encoding this information, and therefore the brain doing Fourier transforms. The difficulty is this did nothing for problems 1, 2, or 3. Who looks at the image? Where does the reconstructive wave come from? How is it processed? How is the image processed? In 1991, he published Brain and Perception, the book Brain and Perception, much more sophisticated, but as you go through it, it still had no resolution to problems 1, 2, or 3, nor any attempt to engage Gibson's theory of perception and the invariance laws defining events. It's as though this very critical piece of information in the external world, the invariance structure, dynamic variance laws defining events, simply didn't exist. And this is a critical thing for any theory to engage, and for all practical purposes, it didn't even exist to engage in Pribram's world. So use of his theories, of course, still carries on heavily. Again, referring back to one's Google searches on the holonomic brain theory, Pribram and Bohm figure very, very heavily. An exemplar is the Holographic Universe series, YouTube series, 5-part series, at least 5 parts. And I'm going to look at it here since it is illustrative of an endpoint to which problems 1, 2, and 3 lead, along with another problem in quantum mechanics we're going to take a look at. This is based on their foundation in the lack of any theory of the origin of the image of the external world. This is where it all derives. But it's worth looking at. Of course, the endpoint is that there's no objective world. That this is all just an illusion. And this is all coming from somewhere. Just remember the number 21 part of the series where we talked about refuting the external world, or not refuting the external world, where the whole world is taken as an illusion. But Garen Backlund, Bernardo Kastrup, and others. This is very ubiquitous, hence worth looking at once more. So in part 2 of the series, we have this kind of a statement. As a hologram functions as a sort of lens, a translating device, able to convert an apparently meaningless blur of frequencies into a coherent image. Again, they're talking here of the reconstructive wave set. They're passing through what would be a blur of recorded information on that plate, and then forming a coherent virtual image of the coffee cup. Pribram believes that the brain also comprises a lens and uses holographic principles to mathematically convert the frequencies it receives through the senses into the inner world of our perceptions. Mathematical conversion refers to the Fourier transforms we noted earlier that Pribram thought might apply. Meaningless blur of frequencies, this is a bad mischaracterization of the information and the light reflected from the environment. This very phrase, meaningless blur of frequencies, again, a bad mischaracterization. It's just ignoring the nature of the external environment, which can still be quite holographic, but still has and carries this information. In other words, it just ignores Gibson. It ignores texture gradients, the height occlusion ratios that account for the size constancy of the cup moving across the gradient. Flow fields, the velocity vectors, the array of velocity vectors that flow field is. It specifies motion. Slant velocities, such as in the flag, or the flow field of the cube, and therefore defining the very form of the cube. Tau ratios, which are mathematical information in those flows used for modulating landings if you're a bird or an airplane. Strains transformations defined over cardioids, defining the growth of the head. All this information in the light is simply being ignored in this statement, meaningless blur of frequencies. And as I noted with respect to, well, actually both the 1991 book and the 1971 book, there is complete ignoring of this entire aspect of Gibson's perceptual theory, as though it means nothing. And this is extremely misleading. The inner world of our perceptions up there. Again, the image is considered to be within the brain, this inner world, or at least This is not direct perception. We're not seeing things where they truly are in the field. At least here, as it's in this statement, actually what this statement becomes, as we'll see, is very ambiguous ultimately as to where they think and what they think the image is. So the piece continues. In short, Pribram believes our brains mathematically construct hard reality by relying on input from a frequency domain. Going on, your brain first receives a hologram in wave frequencies downloaded from the field, a concept we'll have to get to on downloading. It then translates those waves into particles. So it translates those waves into particles. An interesting concept, to create your holographic physical reality. And then it sends that reality out there, again we're projecting an image out there, for you to perceive and experience. So it translates the waves into particles. Now, there was much discussion with respect to quantum mechanics in the double slit experiment that preceded these statements and also that followed this ultimately. And of course that includes the various phenomena around the double slit, the strong detection phenomenon, quantum eraser, etc. I'm not going to go into all of these phenomena. We will be looking at the double slit because this is the source of much of these difficulties. I'm noting there in the bottom there for a demystified explanation of quantum eraser. I put an article in the description. By demystified, I mean it is explanation that removes the whole notion that nothing happens without consciousness. Then secondly, the brain, like the double slit, turns waves into particles. So apparently this turns into particles of what? Of light. And anyhow, we'll go on from there. You can begin to see the difficulties here. But this is coming from the extreme shakiness of quantum mechanics with respect to what light actually is. And ultimately then to the absolutely unannounced divorce of quantum mechanics from electromagnetism and the electromagnetic nature of light in Maxwell's theory, as we discussed in number 22, where a photon can only be an aspect of a wave traveling through the ether. But we'll come to that again. So your brain first receives a hologram in wave frequencies downloaded from the field. It then translates those waves into particles to create your holographic physical reality, and then it sends that reality out there for you to perceive and experience. Now they admit they have no idea how this happens, but nevertheless. So there we have the holographic reality being downloaded into the brain as a coffee cup, whether it's the image within the brain or just neurons, neuronal hologram that doesn't look like a coffee cup yet. And then that's projected via some wave, I guess, into the world out there. So to create your physical reality, so again, is the coffee cup an image in the brain or a coffee cup encoded as a hologram in the neurons, but now of particles? So a set of particles, it somehow then have to become coherent as an image, and then it sends that reality out there for you to perceive. So again, problems 1, 2, and 3. How is it sent out? Where is the reconstructive wave that's passing through the brain? And then, who perceives the image? How is the image processed? Again, an infinite regress, because now you have to have an image processor processing that image out there, just as they say. For it sends that reality out there, looking back to the quote, out there for you to perceive and experience. This means you're now processing the image, perceiving it, and experiencing it. But worse, we have the particle or wave-particle conversion thrown in, and even worse, that download, the blue arrow there. One's wondering if, do we actually even need eyes if we're simply downloading this? Or I guess the implication is we're downloading it via the eyes, but who knows? Very problematic here. Then they go on. Apparently, once our brain converts the wave frequencies downloaded from the field by collapsing the wave function, so the brain does a quantum mechanical collapse of the wave function, it projects the results out there and makes it appear that we are surrounded by a holographic 3D total immersion movie. It would actually have to be a 4D total immersion movie, because there is a minor aspect called time as well, the transformation of this field. While watching this, they say you are not inside the room is inside you. To imagine matter as an existence outside the mind is indeed a deception. But yet, the mind is only in the brain. We're getting confused. We have been conditioned since birth to believe that what we see out there is real, an independent reality that has a life of its own. Not so. We are projecting our reality first, and then perceiving it coming back to us. Again, right back to where we started. We have to have a theory of the processing of the image coming back to us. They quote from Talbot, "If the holographic brain model is taken to its logical conclusions, it opens the door on the possibility that objective reality, the world of coffee cups, mountain vistas, elm trees, and table lamps, might not even exist." At least the word might is in there. Is it possible that what is out there is really a vast, resonating symphony of waveforms, a frequency domain that is transformed into the world as we know it only after it enters our brain? When you see the equivocation here, the world either exists or it does not. It can obviously, it doesn't look like it looks at all to us at the most minute scale of time, what I call the null scale of time. We're getting a time-scaled vision of the universe for starters. And even Bergson discussed the world as a sea of waves, but not to the point where we're questioning whether elm trees and table lamps, of course my elm trees are dying, but elm trees and table lamps might not even exist. Coffee cup, I know exists. Well, at least it's looking at me right now. So they go on. For Bohm, they say, the tangible reality of our everyday lives is really a kind of illusion, like a holographic image. Underlying it is a deeper order of existence, a vast and more primary level of reality that gives birth to all the objects and appearance of our physical world in much the same way that a piece of holographic film gives birth to a hologram. And indeed, one could take this as an implication of Bohm. In fact, implication being the primary word, implicit order. And this is where we're going to diverge a bit in Bergson versus Bohm, but we'll get to that. For Pribram, the synthesis made him realize that the objective world does not exist. Then the equivocation, at least not in the way we are accustomed to believing. What is out there is a vast ocean of waves and frequencies. Again, no one will dispute that the world taken at a different scale of time doesn't look like this world. But we keep veering toward this non-existence of the world. And in reality, it looks concrete to us only because our brains are able to convert or take this holographic blur and convert it into sticks and stones and other familiar objects that make up our world. Now for Bergson, the field is not a blur of frequencies. He stated in effect that definite objects exist. My terminology here, suns, moons, trees, frogs. They simply do not have the precise outlines, the definite borders we assign to them. Again, he was talking of space in terms of extensity, not abstract space, which is the continuum of discrete points. The field is yet holographic. It still fulfills the criterion that at every point is the photograph of the whole. And he still saw it as a vast sea of vibrations shimmering everywhere, but yet within it with a definite object, suns, moons, trees, frogs. Just not looking at that in this form until we take it to a certain scale of time. So there's a real difference going on here, as you can see. They go on. If the concreteness of the world is but a secondary reality, and what is out there is actually a holographic blur of frequencies, and if the brain is also a hologram and only processes some of the frequencies out of this blur, what becomes of objective reality? Put quite simply, it ceases to exist. Now, you just can't say that. I mean, that does not follow. And at this point, the narrator says, there is no out there out there. So these kinds of positions just want to veer to no objective reality so badly they can't restrain themselves. Now, a few experiments are discussed at this point. For example, experiments like Libet, where there's an awareness of intent only after one sees the intent forming as a brain wave, and a precognition demonstration discussed by Dean Rodden. And then the comment is made. The only conclusion that makes sense when you put all these experiments together is that wave frequencies are being downloaded to the brain from the field, which are then translated into a particular particle that is a particle-like hologram. So somehow we have a hologram that's just particles, not waves, and project it out there to perceive and experience as reality. Then they ask, is there one big hologram of the universe that we all see and are a part of? Isn't that what is meant by the holographic universe? And the answer is no. If there were a common hologram, then each would see reality exactly the same. And that doesn't happen. We all see reality a little differently. And that is given the example of Brad Pitt. Some see him as handsome, some folks do not. And of course, there's any number of such differences in perception. And given the complexity of the brain and the unique history of each of us, and the fact that the state of the brain at any point in time is a unique reflection of the entire history of all previous states, so to speak, then yes, there has to be some differences in perceptual specification. But always ignored in these discussions where we're proposing that there is no objective reality is Gibson and those invariance laws that define or structure events. Again, simple example, the flow field as we go down a road. A gradient of velocity vectors with a precise mathematical specification, where the velocity of each vector varies inversely as a function of the distance squared from the eye of the observer. Precise mathematics, and that these then constrain perception and force commonality, that is, common perception across all of us. So how this is continuously dropped in these types of discussions is, to me, quite amazing. So they go on. So each individual must have their own unique hologram they are projecting for our own private reality. We are each receiving our own personal holographic downloads. They go on. Besides, if there were one giant hologram we are all part of, it would mean there would be an independent, objective reality out there. And all the experts say that's not true. A couple experts, Fred Allen Wolf, Lynn McTaggart, who wrote The Field, both are quoted as saying there is no out there out there. And we saw this in number 21 with Bernardo Kastrup Aaron Backlund, if you're in the external world. They'd say too, there's no out there. So what is a download? So they ask us the picture over on the right. Who or what is the laser that chooses the holographic 3D total immersion movie to download to your brain for you to experience as your reality? Well, it's consciousness. So consciousness is what chooses the specific wave frequencies from unlimited possibilities in the field that consciousness, wants and downloads them to a human brain, which then converts them into space-time particles, and out pops our holographic reality, our 3D surround/immersion. So at this problematic point, this is where we're going to quit. I mean, I'm still not quite sure whether the download is directly to the brain or through the eyes, because there's the implication that the eyes are simply looking at the image that's projected out there, and we have that whole problem starting again. But this is where we get to with some of this if unconstrained. And some of this comes from the double slit. So we'll be going there in a bit. But I want to return to Bohm for a moment and the three problems. The critical difficulty here with Bohm and the three problems. For Bohm, we saw envision the universal field as a holographic field. In this, he saw the hologram as an example of an implicit order. And he gave two examples of an implicit order. The hologram, where we saw the two waves, the reference wave from the laser light and the object wave reflected from the scene, the pyramid and ball, coming together at the plate, interfering, forming an interference pattern that looks nothing like the pyramid and ball. Encoded, implicit in that order, in that interference pattern on the holographic plate is the pyramid and ball. So it's an implicit order. The glycerin cylinder, we took an ink drop and it was put in the cylinder and turned and turned and turned, and it became attenuated and ultimately invisible within the glycerin. So again, the order of the ink drop is in there, but utterly invisible and implicit. And then he gave two examples of unfolding in an explicit order from the implicit. First was driving the reconstructive wave, or passing the reconstructive wave, or beaming it through the hologram. Then when we beam it through that interference pattern, out comes or specified the virtual image, the original scene, the original explicit order. Or unwinding the implicit ink drop from the glycerin cylinder, if we unwind enough, out comes the original ink drop, the explicit order of the ink drop. And so one could ask, well, how does the brain unfold an explicit order from the holographic field? That is, how does it unfold a coffee cup from the field? He had two choices. First, the brain unwinds things like a glycerin cylinder. Somebody turns a crank in the brain and unwinds the embedded coffee cup inside the brain, and out it comes. Now, this is obviously absurd. The glycerin cylinder and its unfolding of ink drops is an abstraction with not even a vague way to implement it within the brain. And he knew this. And then there's Bergson's model, where the brain acts as a modulated reconstructive wave passing through the holographic field and now specific to a source within the field, i.e. the coffee cup. But he did not take this choice either. So he didn't take one or two. glycerin cylinder, obviously absurd, but the very method of unfolding an explicit order out of a hologram, namely via a reconstructive wave, he never mentioned in his book, Wholeness in the Implicit Order. Why? Why didn't he take that choice? Number 2. Well, either he could not conceive of it, or he knew he would be left with the viewer, looking at the wave specifying the source of the object wave. That is over in our picture there, the wave again, object wave, coming to the eye of the viewer, specifying the source of that wave as the little buzzing fly. Which is to say, he was left with the who, the homunculus observing the image, and that would still be there. And thus the how also, for how is the externally specified image now processed. And in my guess, he did not know how to resolve this. To resolve this, to remove that viewer, you require Bergson's insight. The relation of subject and object must be put in terms of time, where time is indivisible flow, where there's no spatial distinction between the body brain there and the little buzzing fly in that field. Now, Bohm's holo movement, as he describes it, is very close to the notion of time as an indivisible flow. He talks about the unbrokenness of this movement. But he didn't make this move. And then you need the brain as a reconstructive wave being specific to a time-scaled form with the elemental awareness defined throughout the holographic field, i.e. the little fly, or the fly could look like a buzzing, like a butterfly there, slowly flapping his wings. A scale is specified. And that elemental awareness, as we noted, comes through its indivisible transformation, that is the field's indivisible transformation and its holographic properties. And Bohm had even enfolded consciousness within the holo movement. But yet, he did not make this move to treat the brain as a reconstructive wave passing through his implicit order in his holographic field. So this is simply my guess as to why he didn't make this move. To me, it's quite perplexing, but this is what it is. So, but in Bohm, we do not see no objective reality. He never says that. Or the brain turning waves into particles, not even close. Or the brain projecting an image out there, not even close. He doesn't go there. Or personal holograms being downloaded from the field by consciousness, not even close. These approaches are a vast distortion of Bohm and of Pribram as well. So yes, Karl left the 3 problems in his wake. But without a solution to these, building an even more questionable edifice upon this vacuum is, well, pretty questionable. Now, much of this excess, in my opinion, comes from the darn double slit. So let's recourse back to that for a moment. And of course, from its interpretation, with people like Mr. Quantum floating around. Now, the double slit experiment is the foundation of QM, as Feynman noted. In number 22, we saw an unavoidable conclusion. The photon can only be an aspect of light taken as a perturbation of the electromagnetic field, that is the ether, where the field's dual principles, the dielectric, the magnetic, are in a ratio per Maxwell, which defines the propagation velocity, and this ratio is always c. If you don't hold this with respect to the nature of the photon, effectively, you have simply divorced from the entire science of electromagnetism. The photon simply exists as itself, as not being some aspect of this perturbation of the field with its magnetic and dielectric aspects. You simply divorced out from electromagnetism. Now we saw too deBroglie's solution, where the photon is indeed but an aspect of an underlying subquantum wave. And again, it was hard to escape. This wave, the subquantum wave, is the ether. Now it was deBroglie who was at the very heart of the double slit and the birth of quantum mechanics. So deBroglie, in his 1924 thesis, had predicted that even particles had a wavelength. That is, even particles, actually any object or objects, have wave properties. For example, Mr. Rat over there to the right has a wavelength, lambda, a function of Planck's constant, h, over his mass and velocity. deBroglie had noted or felt that Bergson had created the general mindset or zeitgeist in that period of 1924 that allowed this move. Just remember as an example, Bergson's description of the universal field as a sea of waves, an immense sea of waves vibrating everywhere. So no, this was not Heidegger in 1927 with being a time that did this. This is Bergson. A point we'll come back to, Heidegger versus Bergson, perhaps sometime. This led to the Davison and Germer experiment in 1927, showing that electrons beamed one by one, that is particle by particle, still create a diffraction pattern, that is a wave phenomenon, and therefore the verification of what was considered a very far-out prediction by deBroglie. But there was another aspect to the 1924 thesis, and this was deBroglie's law of phase harmony. And that we'll go to now. I note there that this can be seen, described rather succinctly in the Haas article. I'll link in the description, starting in part 2 of that article. So the law of phase harmony. This involves two frequencies. The first is the inertial energy frequency for deBroglie. So every quantum of energy is associated with a frequency, a quantum of energy, and that relation is given by E, energy, equals h nu, where h is Planck's constant and nu is frequency. Now, just as an aside here, one can ask what actually is Planck's constant, h. It's a tiny little number, 6.626 times 10 to the minus 34 joule seconds. But it's always interesting to realize that these constants, these strange little numbers, have to have some rational basis in physics. So often they don't, they just kind of exist. But just as an example, for Jacob Kessler in his book, The Energy of Space, he saw it as the minimum energy amount required to expand the ether to its elastic limit, just like jello, thus creating a wave. So we're visualizing the ether as a medium with an elasticity and a density, and there's an amount of energy required to make a wave in this ether. So given an amount of energy E, then that must cause the ether to vibrate nu times, that is the frequency per second, h nu, sending out these waves. So you impose an energy E on the ether, and it's got to vibrate nu times, each time giving off this little amount of energy through the ether to give off that amount E in 1 second. So that kind of becomes just an example of what maybe a rational basis for this little Planck constant h actually is. But moving on, every quantum has an inertial mass at rest. That's given by the Einstein equation, E equals mc squared, E0 being at rest, m0 mass at rest. Now combining these two equations, basically just substituting the h nu for the E0, we get this equation, h nu 0 equals m0 c squared. So it's kind of amazing how simple what deBroglie was doing in terms of the math, at least up to this point. Now the particle moves at velocity v. So it moves at velocity v, and then the associated frequency increases. And so we get h nu I, the frequency, frequency in motion now equals v, the velocity, times h nu 0, the original frequency at rest. And thus canceling the h's out in both sides of the equation, we get nu I, the new frequency in motion, equals the velocity v times the original frequency. So an increase of frequency with velocity. Now we got the second frequency, the clock-like frequency, which came from Einstein. The same particle has an inner frequency for Einstein, like a tiny clock. So each particle has a frequency like a little tiny clock. And we'll call nu c, or nu sub clock, frequency of the clock, clock-like frequency. Now the two frequencies are identical at rest, but when the particle is put in motion, the two diverge. And so you have nu I equals, in motion, the velocity times nu 0. And then you have the clock frequency, which becomes 1 over v times nu 0. Notice the two frequencies are no longer the same, because now you've got 1 over v times nu 0. They're diverging. And this was a problem. They're getting out of phase, out of whack. So deBroglie assumed the inertial energy of the moving particle behaves as a wave-like phenomenon. As we saw, he then postulated the phase of this wave-like phenomenon to be at all times equal to the phase of the inner clock-like phenomenon. So these two, the inner clock-like phenomenon and the inertial energy frequency, both frequencies are always the same. They stay in sync. The harmony of phases resulted in a superluminous, that is faster than light, wave velocity, call it v sub wave, connected to the particle velocity, v sub particle, where the two are related as v sub wave is equal to c squared over the velocity of the particle. Now, all this was considered fantastic, too much to be true. Historically, it was actually Einstein's backing that actually got the thesis approved over the hurdle. Einstein shifted, so to speak, to Germany, and thus it ultimately arrived at Schrödinger, who based his wave equation on deBroglie's postulates. There followed closely Davison and Germer's confirmation. The interpretation of deBroglie's postulates soon became a central problem of quantum mechanics. Quantum mechanics became the interpretation problem. The idea of an inner clock-like frequency associable to an electron as a particle disappeared from the scene. All attention focused on the nature of the matter waves connected to the inertial energy. Then came the final interpretation of the Copenhagen school with Niels Bohr. The moving electron completely evaporated in the wave. The inertial wave transformed into an abstract probability wave, disconnected from physical reality, and effects became dependent on observation. The Copenhagen school interpretation has been on its perch ever since, and no one's been able to knock it off. And thus we come to this effects dependent upon observation. So the double slit. For Feynman, all of QM can be derived from it. That is, it contains all of QM. Rather, I would rather say the history of the double slit contains all of QM. And this, unfortunately, is a movie of a strange social, psychological, cognitive dynamic, where the origins in deBroglie have been stripped out, and unbelievably, its basis in electromagnetic theory. And this does not even count the social dynamic history of SDR and the acceptance of its totally inconsistent interpretation, the relation of which we'll touch in a moment. If we return to the beginning, we have a phenomenon that is both particle and wave simultaneously. Call it a particle with wave-like properties, whatever. It is not a particle at one time, a wave at another time. Its particle-wave nature cannot be dependent on observation. It is a singular entity with origins anchored in the ether. Now, Shanahan gives a relativistic take on deBroglie in the same aspect. Again, for deBroglie, a massive particle could be associated in its rest frame with a characteristic frequency, nu-0, as we saw. Or when expressed as an angular frequency, it looked like omega, the angular frequency, is 2 pi nu-0 equals mc squared over h. deBroglie thought this frequency absolutely real. He argued that a massive particle must be surrounded in its rest frame by a periodical phenomenon which he assumed has the form of a standing wave. Just another take on the law of phase harmony we were discussing. In his thesis, he did not apply the Lorentz transformation, yet he held to an observer for whom the particle is moving at a velocity v, the standing wave becomes a superluminal wave of velocity c squared over v, as we saw. So you've got this superluminal wave, faster than light. It appears to be anti-relativity, but deBroglie resolved this by saying that that wave was not carrying energy, so it didn't violate relativity. Constraint on the speed of light being the fastest speed. deBroglie referred to the superluminal wave as a phase wave. Now we noted that deBroglie didn't actually apply the Lorentz transformation in his thought in his thesis, but what happens if you actually do? So imagine you're an observer, down on my bottom right there, watching this particle, and it's moving at velocity v. Then for such an observer, the standing wave associated with that particle now becomes a carrier wave of that velocity and subject to a phase modulation. And this modulation is the wave characteristics in superluminal velocity c squared over v of the deBroglie wave. Now, when we're applying the Lorentz transformation, I've circled the Lorentz transformations up there that are relevant. You've got the x prime, or the new length, involved in the particle, and you've got the new time, t prime, involved in the particle, in the moving particle, as from a stationary Mr. Longhair there point of view. That these are the fundamental Lorentz equations. We'll get back to those. So it's this modulation that is the true deBroglie wave, Shanahan argued. And if the deBroglie wave emerges from an antecedent wave, with which it must therefore share an ontology, a physical origin, it becomes possible to speculate that for a massive particle, even an electron, this underlying wave moving at the velocity of the particle might explain both the wave and the particulate properties of the particle. So again, for this purposes, Shanahan, we're again going back to the fundamental wave particle nature that exists here. Not one at one time, not at another time. Not particle once at one time, wave at another time. But in the very origins of the Broglie, we've got this underlying standing wave that can become a phase modulation in this situation. In applying the Lorentz transformations to the moving particle / standing wave, Shanahan is not actually using special relativity, though he claims that he is. This is an egregious, albeit ubiquitous, intellectual disservice. Special relativity, its entire structure, is in reality a system of illusory effects. A system of illusory effects. The effects come and go, depending on which observer is fixed upon as at rest. Again, in the twin paradox. If the rocket twin, or Brad Pitt to the right there, is regarded as moving, he indeed has retarded aging. He looks like Brad Pitt compared to his brother. He's left on Earth, now the old man. But let's put the original Earth twin on the rocket, and we'll let the original former Brad Pitt be on a rocket that's simply holding its place in space, and the original Earth twin now goes out and back. Now he looks like Brad Pitt. In other words, now that the original rocket twin is stationary, he's aging normally. So the effects come and go. I used a little rocket there for the new Brad Pitt because it's more difficult to visualize the Earth moving back and forth away from the rocket, but one can do that. And in 1918, trying to preserve his reciprocity, they have his cake and eat it too, Einstein proposed exactly that if the Earth is conceived as moving back and forth, and the rocket engine simply neutralizing that movement that is holding its place in space, stationary, then indeed we have reciprocity. The Earth twin now ages less and comes back riding in his Earth rocket ship looking like Brad Pitt. But then he argued, but huge gravitational changes would be required. And so the Earth twin, while riding the Earth, would be aging more quickly anyhow. And so he discarded that as a possibility, which is entirely disingenuous and a red herring, because in relativity, there is no consideration, no room for consideration whatsoever as to the nature of the systems that the two observers are in, whether large gravitational systems like the Earth, or whether it's simply two dinner plates. Again, each one can be riding a dinner plate back and forth, and if one is in motion and the other one at rest, the one in motion will have the retarded aging, or the new T prime, according to the Lorentz transformations. Look at those transformations up there. They involve nothing but time, velocity, velocity of light, and distance, x. There is nothing to do with mass, gravitation, or anything involved in that. So what Einstein did, he just added in these two ingredients to those four Lorentz transformations. First, this fundamental reciprocity of observers or reference systems, where each observer can claim himself at rest and all the other observers in motion, and no one can say any different. It's perfectly reciprocal. Some other observer can say he's at rest and the other in motion. And then the invariance of the speed of light. That is, Light travels the same speed no matter what the state of motion is of any observer. Simply pour those two ingredients in or add them in to the Lorentz transformations and you get special relativity. Without those two ingredients, both of them, special relativity is gone and you just have the original four Lorentz transformations. So the effects in special relativity have no actual ontology. It's just this math combined with these two postulates. And this is inherent, then, intrinsic to the reciprocity structure of STR, this no actual ontology, no true physical effects. If you try to treat the effects as real, as physical, the logical consistency of this reciprocal structure of transformations collapses. This was the essence of Bergson's argument, or better, warning, with respect to the future confusion that was going to arise in his duration and simultaneity of 1922. I find it interesting that when I wrote a critique of a couple books by Andrew Thomas that involves special relativity, and I noted this fundamental problem that you're ignoring reciprocity, he wrote in response rather angrily initially, but involving this reciprocity notion that's kind of quaint, and he's never seen that term before, which I think is an index to how badly the original nature of special relativity has been obscured in the teaching and training of modern physicists. So now in the double slit and in deBroglie's laws of phase harmony, we're talking real ontological effects. Real particle waves moving through real slits, real diffraction patterns being formed, real wave interference. You can't treat real effects via a system of illusory effects with STR. Shanahan says of the particle's waves that there is, quote, a failure of simultaneity in the direction of travel once you apply the Lorentz transformations. But no, the Lorentz transformations used outside of Einstein's framework and his special relativity do not mean the breakdown of simultaneity. It did not mean this when Lorentz formulated the Lorentz transformations. This came only from Einstein's framework, in which he put the Lorentz transformations, the two ingredients. The two lightning bolts are not simultaneous, he argued, since an observer's clock are not necessarily synchronous, because if he's not at rest, and he doesn't know he's at rest, he can't tell. That was the fundamental start. It was the claim that there was necessarily no simultaneity because you can't know whether your clocks are synchronized, because you could be in motion or not. In other words, reciprocity, that started all this, not Lorentz. And further then, Mr. Green there can't prove that he is at rest. Another observer can claim that he's moving at a velocity v, therefore his clocks are no longer in sync. That is reciprocity, because it can go vice versa. Mr. Green can say, no, Mr. Black, you're in motion. I'm at rest, and my clocks are indeed simultaneous. This is the framework from which it started, and the Lorentz transformations were put in. But if you just apply the Lorentz transformations outside of this framework, you don't have any of this. Shanahan says of the particle's waves, quote, time is retarding. But no, time is not retarding. There's a slowing down due to velocity of physical processes by which we measure time. It is a local time. That is, the processes in that clock there are slowing down if the clock is in motion at velocity v. But STR has no physical explanation, no physical model of this retardation of processes other than that abstract mathematical application of the Lorentz transformation with its T prime. If one looks at 8a, slide 69 to 72, for example, you can see what such an explanation, what such a model might look like as an example. But SDR has no ontology, no actual physical models. Lorentz at least understood the necessity of this. He adduced electrodynamical arguments for his time and length effects, trying to explain Michelson-Morley. That is something physical, a physical model to give physical meaning to the abstract mathematics of his Lorentz transformations. For example, in the Michelson-Morley experiment, the apparatus arm, the horizontal arm there, facing the ether current flowing against it, contracts according to Lorentz's formula there. The new L as a function of L prime and that factor of the velocity of light and its velocity. So it's an actual, but he had an actual physical model for this length contraction of the apparatus arm. So that's outside SDR. Inside SDR, illusory effects. Outside of SDR, you can have real physical effects. Shanahan is simply using Lorentz, pre-Einstein Lorentz, pre the reciprocal structure of special relativity, raw, unmodulated Lorentz. As Bergson called this, it's half relativity. We apply the Lorentz transformations one way and completely forget reciprocity. Ignore it. Ignore that that application could be reversed if we look at a different observer and a different as being at rest. In other words, this is no relativity whatsoever, no special relativity at all. But this is lending special relativity credence. When you have writers like Shanahan, theorists like Shanahan, saying they're applying special relativity and to the very foundations of QM, you're lending it a credence, an aura, a status it does not deserve. And this is done continuously. It helps maintain its mystical status to include its completely invalid view of time, the absurd frozen space-time block of future, past, and present. Never to change, all laid out already with all of the logical absurdities that this involves. And the so-called remarkable twin paradox, which is remarkable and a paradox only because it truly destroys the entire reciprocal structure of relativity and all of relativity. And then the myth that Michelson-Morley has been resolved. Sorry, but it has not been resolved. We are using Lorentz, period, not special relativity. We're using raw Lorentz, and here with deBroglie's phase wave at the very foundation of QM. We've got to get clear on this and remove special relativity from the scene. So if we remember these things, keep them in mind, the loss of the original implications of deBroglie, the surgical removal or the hidden divorce of the science of electromagnetism from this entire subject, the fact that we are dealing with a simultaneous particle wave with very little question about it, this would remove the tendency towards implications supposedly derived from the double slit, i.e. there's no objective reality, that every event depends on the observer for its very existence. And thereby, those unwarranted, very questionable conceptions of Bohm, of Pribram, and of holographic theory as applied to mind and brain, in my opinion. So down the road, again, physics and the holographic principle, time travel, yes, no, possibly, temporal consciousness, philosophical treatment thereof, current memory research related to Bergson. I'm thinking of one, quantum mechanics at the origin, that is, at the very origin of the notion of quanta. And this is in the black body radiation experiment, photoelectric effect. That is, if I can dig up my notes on the subject, a topic I'm calling the memory of spiders, which is where is instinct stored. For these little beings, little spiders, little insects bring incredible skills, knowledge, and practical in behaviors that one wonders, well, how are they carried from generation to generation? What is the mechanism for that transmission? An interesting question. And relates to even things like learning piano concertos, for that matter. And then Heidegger, looking at this because Heidegger is considered universally as the 20th century's greatest philosopher, whereas Bergson is somewhat relegated to the status of who is Bergson. And I'm thinking of a little throwdown, shall we say, between the two as to who has the most interesting significance. I'm not so worried about status, ordering, ranking, but what does worry me is the tremendous emphasis given to Heidegger, I fear, is obscuring what is an incredible vision and practically implementable down the road of mind, brain, perception, and consciousness that we've been looking at, or something else. So next time we'll see. Until then, signing off.